Well, good afternoon. First of all, I'd like to apologize for the sudden change. Erica was supposed to be presenting today, but unfortunately, she's feeling unwell. So I'm kind of presenting on her behalf. And today, I'd like to switch gear a bit. We'll talk about a little bit about the implementation instead of high-level pictures. Am I too far? There you go. So this is the agenda. First, I'll start with a company introduction, and then we'll talk a little bit about the applications of indoor tracking using Wi-Fi. And then we'll talk a little bit about the challenges that we've encountered so far with indoor positioning. And finally, talk a little bit about how this all fits within the IoT framework. As a company, we're a local Hong Kong-based company. Our focus is in the implementation of indoor tracking. But indoor tracking is basically an infrastructure technology. You can take indoor tracking and apply it in many technologies. And we, as a startup company, we don't build the end-to-end solutions, but instead we work with partner companies who integrate our solutions and our technology and then tailor it for specific applications. And today, we'd like to talk a little bit about what we've done in the healthcare environment. Throughout our work with different companies and different projects, we've seen quite a few challenges in indoor positioning, and then we solved them through experimentation, research, and development. And some of them we'll go through today so that you get a feel of what kind of challenges that we get in indoor positioning. First of all, about technology overview. When we think about positionings, we automatically think about GPS. Well, GPS is a technology that was created specifically for a purpose of positioning. We all know that GPS is based on satellites in the sky. It works very well when you're outdoor, but when you're indoor, you cannot get satellite signals, so GPS doesn't work very well. There are a lot of indoor tracking technology that's been introduced in the past. We spoke a little bit about several of them this morning. For example, RFID, iBeacon that is based on Bluetooth low energy. And then we also have Zigbee that is becoming more and more popular. But when we apply indoor positioning to some healthcare applications, one of the key requirements is that it has to work anywhere. It has to work outdoor, it has to work in your flat, it has to work in an MTR, it has to work basically everywhere, right? And when we require a technology that's ubiquitous as that, basically it narrows you down to two different technologies, which is cell tower, mobile tower, and secondly is Wi-Fi, because these are the only true ubiquitous technologies for indoor tracking. In our work, we've been focusing on Wi-Fi simply because comparing a Wi-Fi with mobile tower, Wi-Fi seems to be more accurate in our experiment. So right at this point, right, we know one thing. Outdoor tracking is based on GPS, a technology that was built specifically for positioning. However, for indoor tracking, we rely on telecommunication infrastructure. So when we compare the two different systems, two different architectures, the approach has to be completely different. Indoor tracking is generally based on what we call real-time location system, or RTLS. It follows the IoT infrastructures actually quite nicely. For the tracking devices, we have sensors. In the picture over here, we have the red, yellow, and blue tracking devices. These are simple sensors. If these are Wi-Fi tracking devices, all they do is that they collect signal strength from the surrounding Wi-Fi access point, and then they turn around and they send it to the location server. The location server is where most of the intelligence is. It has a knowledge of the entire devices that we deploy out there. It also has knowledge of the floor plan. It also has knowledge of the fingerprint map and also the locations of each access point within the floor plan, right? And consistent with the Internet of Things technology, we can supply the collected data to an analytics server, so you can analyze the data in so many different ways. You can tell, like, this particular tracking device how much time it spends at which locations. You can tell like what kind of alerts that's been raised by each tracking device and what kind of battery level history that you have for each device. All that integration is possible. And finally, there's a user interface tracking device. Basically, the function of the user interface is to determine where the tracking devices are. Right. So the communication protocol between the tracking device and the location server is the M2M follows the M2M communication model. So as you can see, basically the indoor location technology follows the IoT architecture quite nicely, and that's why we've been able to integrate that into an IoT solutions quite easily. So some of the applications of indoor tracking using Wi-Fi in healthcare, the most obvious one is for tracking the elderly and children. This morning here, we heard the term that was used, which is healthy aging. So that's the kind of applications. So for this, as I mentioned, it's an application that has to work everywhere, especially in a place like Hong Kong, where people spend a lot of times underground or indoor, right? We need a technology that works outside and also inside. We typically use GPS for outdoor tracking and also Wi-Fi for indoor and outdoor. So the question here is that why do we need Wi-Fi for outdoor if we already have GPS? It's because even when you're outside and we use GPS, it has to have visibility to at least 3 satellites. Unless you have visibility to 3 satellites, GPS doesn't work, right? So if you're sitting in the middle of 2 tall buildings, having a clear view of the sky doesn't work. But in those cases, we can still leverage GPS. We can still leverage Wi-Fi. There are 2 ways that you can use Wi-Fi in this kind of environment. The first approach is basically to leverage the existing location services. And there's quite many Wi-Fi databases that already exist. Some of them are Google Location Service, MLS. They have millions and millions of access points database already in their network. One database that I know, they claim to have 900 million access points in their database already. So we're not planning to reinvent the wheel. Like we leverage whatever service that's already available out there. And in a lot of cases, especially in a public area, such as airport and shopping mall, the accuracy is pretty good because they actually survey those areas, right? And the example over here is that we have this little girl who's inside Festival Walk, and Google location service is accurate enough within that environment, right? But if you have used Google location services at all, you'll realize that the accuracy when you're inside private area becomes less. When you're in your own flat or when you're in your office, for example, Google location service would show that you're outside the building and not inside the building. That kind of accuracy sometimes is not sufficient because if you live in a high-rise or if you're inside the high-rise, right, you could be anywhere within that high-rise, and to locate a person given that information that you're outside may not be sufficient from time to time. For that, basically, we apply something that's called customized tagging. So basically, when you know that you're a certain location, for example, in your own flat, we have the ability to tag that locations. And basically, what it does is that it associates the Wi-Fi access points that's visible from that locations to that location. So the next time you or any device that you own enter that location, it associates that with that particular location just by looking at the Wi-Fi fingerprint, right? And this information is private. So basically, if you tag a location to be your bedroom that is not visible to anybody else who uses service, that's only useful to you. You probably don't want everybody to know where your bedroom is. So that's basically the technology that we use, right? In terms of tracking device, somebody mentioned this morning that smartphone is actually a very good tracking device, and we completely agree. For this particular applications, smartphone is preferred compared to a dedicated tracking device. For example, I have an 11-year-old daughter, and her mother really wants to know where she is all the time, and she never forgets her mobile phone. But if we give her a GPS tracker that she hangs on her belt, I'll guarantee you she'll never carry that. It's the same as my father, who's 80 years old. He's still driving, which scares all of us. So we care about where he is and whether or not he's okay. Even for him, who's 80 years old, he doesn't forget his smartphone. But if we give him a tracking device, he will definitely not carry that around, right? So for this type of application, we found that having a smartphone app that runs on their smartphone is actually the best tracking device. And another nice thing about using smartphone as tracking device is that you can integrate that easily with Bluetooth wearable devices. Maybe you want to have a Bluetooth bracelet where you have a button that you can press for SOS that can monitor heart rate, for example, that raises an alarm if it detects a stop in heartbeat. That's also possible with smartphone applications. In the map here, we show that there are two maps. They're both based on Google Map. We offer selectable map. We can leverage the Google Map, but in some cases, we do want customized floor plans. So you may ask, like, why do we need customized floor plan if you already have Google Map? It's because there are a lot of areas, especially private areas, that are not covered with Google Map. For example, your flat, right? Google Map doesn't have the floor plan and exact location of your flat, and even office buildings. Google Maps doesn't have that. For public locations like shopping malls, they have a pretty good map, but this is why we have custom floor plan for some private areas, basically. And the second reason that's quite important is the privacy of tracking information. Some organizations and some people just don't want to send their locations to Google because it's a public service and they have their own privacy policy, but they want to confine all their tracking informations to just within their own system, right? So that's the reason why some people still prefer to have their own floor plan, and we support that too, as what we see in this application over here. The second healthcare-related applications for indoor tracking is what we call the staff and visitor safety and locations. Some examples over here is that healthcare workers in unsafe environment, nurses who work at night in a mental hospital is quite the dangerous kind of job. So we offer tracking here. As you can see over there, we use the hospital floor plan instead of Google Map, and that works too. And another application is that you can tag visitors to hospital, for example, so that you know if they wander off to certain restricted areas, sensitive areas that they're not supposed to go to. In US, they also use this particular technology for school teachers. In the case of disaster or violence, it's in case the teacher presses an SOS button, it'll notify the local police who will come directly and provide assistance, basically. Now, if you think about it, right, this is more of an enterprise kind of applications than residential applications. And for this type of enterprise application, what we found is that it's more practical to have a dedicated device. Like, for example, in this case here, we have a Wi-Fi badge. So basically, it's a badge that collects Wi-Fi information with a Wi-Fi sensor and sends that information to a location server that performs the same kind of thing as the smartphone app. The Wi-Fi badge here is equipped with a SOS alert button, and when the SOS alert button is pressed, it automatically notifies security who knows exactly where the button has been pressed and can send assistance there. And there's a display here that you can use also to broadcast messages. So in case there's like, you want to broadcast weather reports or emergency situation, you can do that too. And finally, you can impose a geofence area to implement area restriction even in indoor environment. Wi-Fi badge. Okay. Next, I'd like to talk a little bit about the challenges, some of the problems that we've seen when we implemented this kind of solution, as well as what we found the solutions to be. The first is that one of the questions that I keep getting is that Google Plus already has some sort of location sharing services. Why can't we use Google Plus for tracking instead of building a whole new system? The short answer is shown in the box there. Basically, there's a difference between location sharing and location monitoring. And location monitoring, or what we call location tracking, requires greater trust. And what do I mean by that? First, let's define location sharing versus location monitoring. The picture of location sharing is shown there in the middle. The red phone there, basically it broadcasts its locations to the yellow phone and the blue phone, so that the yellow phone knows where the red phone is, and the blue phone also knows where the red phone is. And the other two phones are basically doing the same thing, so they kind of know where each other is, right? This is what you can get from Google+. If you will, it follows kind of the peer-to-peer model. Whereas how do we define location monitoring is that we have tracking devices. The picture on the left there shows the red tracking device, a yellow, and the blue one, all sending the information to a common server. And from the UI there, the person who's monitoring the service can see where all the tracking devices are. So the scenario there, an example is like tracking the elderly. Like when I'm monitoring my grandmother, I know where her location is, but she doesn't need to know where I am. So if you will, it's more similar to a client and server kind of application, right? So the major difference between the two is who has the information control. In location sharing, the information is being controlled by the person who's carrying the device, who's carrying the phone. They can shut it off if they want, or they can share it if they want, right? Whereas in the case of location monitoring, the person who's doing the monitoring has control of the information. This is important because when you think about the kind of information that we need for location tracking services, there are a lot of information that are just not shared. For example, location history. When you do sharing, you share the current locations, but you never share where you've been in the past 24 hours with your friend. That information is considered too private. And the second is battery level. When you have a phone and you're sharing your location using your mobile phone, you don't send with you the battery level. However, as mentioned earlier, battery level is actually a very important things that you monitor when you're doing tracking, because if the battery goes out, then you lose visibility of this thing. So what you want is that you want the system, when the battery level goes below a certain level, it will send an alert so we can tell the person who's carrying it to recharge the tracking device or so on, right? So what we're saying is that in location sharing services, all this information are not shared, not because they're technically impossible to do, but because there's no such trust relationship between the person who's carrying the tracking device and the person who's monitoring it. And this goes back to the privacy policy. And this is one of the challenges that we face when we try to use Google Plus location sharing services for location monitoring. And that's the reason why it's necessary for us to develop a separate system to perform only for the sole purpose of location monitoring. The second question that I normally get is that why do we need to develop a separate tracking device when we can get a cheap Android phone? The answer is it has to do with the accuracy of smartphone. When you think about it, what is the ideal tracking device? RTLS, that is based on signal strength, relies on one single mathematical relationship, which is shown over here, which is that signal strength is inversely proportional to the square of distance. What this means is that if I am standing at one place and I know what the signal strength of an AP is at this location, right, I can calculate the distance between the tracking device and the access point. If I can see 3 access points from where I'm standing, then I know the distance between the tracking device and the 3 different access points. I can use triangulations to determine the locations of this tracking device. So this formula here is the whole basis for indoor tracking using RTLS that's based on signal strength. By the same token, a technology that is based on this should only depend on the signals, on the distance. What I'm trying to say is that if this is your tracking device and I turn it like that, right, it should give me the same signal strength reading because I'm standing at the same location, I haven't moved. I want to see the same signal. There is a very economical, a cheap, and typical Wi-Fi antenna that has this property, which is the omnidirectional antenna that we've shown over there. As you can see from just by the symmetry of this antenna, no matter which way you turn it, you're going to get the same signal reading. So this is the ideal antenna for indoor location tracking. When you look at smartphone Wi-Fi antenna, however, the picture on the bottom right there, this is the Wi-Fi antenna of iPhone 6. It's easy for you to see that how this antenna would give different reading as you rotate that around. So the accuracy of this device would be impacted if you don't orient it the same way as when you took the previous reading. On top of that, different smartphones actually have different antenna designs. This is just the antenna design of an iPhone 6. A Samsung phone, different type of Samsung phone would have different Wi-Fi antenna design. And on top of that, further, even, well, based on our experience, if you take two mobile phones, the same brand, same model, a lot of times they have different signal readings as well. So basically the answer is that the challenge that we face in using smartphone as a tracking device has to do with accuracy. If we want more accurate indoor tracking capability, then we resort to a tracking device that we have better control over the antenna as well as the components, and therefore we can make the signal strengths more uniform. The third challenge that we face is what we call the access point solution. This is probably one of the most important challenge that we need to take care of. What do I mean by that? When I'm standing over here, when I was sitting at my seat, right, I looked at the Wi-Fi that's detected around this area, and I detected 15 Wi-Fi access points. So the question is, for indoor tracking, which Wi-Fi access point do I use? Do I use all 15 of them, or do I use only 3? And then if I use only 3, which 3 do I use, right? First of all, there are a lot of mobile access points. The first thing that we do when we get a list of access points is that we get rid of our mobile access points. As I mentioned earlier, the whole premise of indoor tracking is based on the relationship that signal strength is inversely proportional to the square of distance. By definition, mobile access points, they move around, they come and go, and if we use them for our calculations, it'll completely screw up our calculations. So that's the first thing that we do. The second is what we're seeing is that there's more and more beamforming AP. Beamforming AP is, I see them more and more. They're typically used in stadium and highly densely populated areas. They have very narrow beam to focus their transmission only in one segment, one direction basically. While the actual relationship between distance and strength still has to obey the laws of physics and therefore that mathematical relationship, the problem with beamforming AP is that it is not uniform all around. It's more like directional, right? So it makes trilateration concept more difficult to implement. So that's why for beamforming, in places where we have a lot of beamforming access points, we typically use fingerprinting as opposed to trilaterations. And, oops, I think I moved too fast. And finally, another challenge that we need to deal with is the temporary variation in signals. When I'm sitting over here, somebody walks in front of me, it completely disrupts the signals because of interference, reflection, attenuations, AP instability, and so on. So it's important that we perform the AP selection intelligently, and we do it based on a sample per sample basis. For every sample that we take, we determine which access point that we use. And my last slide here, as you can see that our implementations implement machine-to-machine and IoT framework among the devices, system, and services. The tracking devices would send tracking environmental variables directly to the location server without any user intervention. And the location server would send back configuration information directly to the tracking device. So basically the machines talk to each other. I'm told that my time is up, so I'm going to finish this. So additional information can also be integrated, like body temperature and so on. And the additional information that we collected can be uploaded to an analytics server. So that concludes my presentation. I thank you for your attention.
Okay. Thank you, Mr. Fan. Are there any questions for Mr. Fan today? Yes.
You mentioned that you are using fingerprint.
Yes.
That may require several base stations.
Absolutely.
And yet it takes a lot of calibration before.
Yes, absolutely.
If the area of coverage is very large, then how are you going to do it?
We typically, if the area is large, then it's a compromise between the accuracy and also the time that you want to spend. You're absolutely right that there is definitely one thing that we have to pay attention for fingerprinting. But when we consider the alternative that's related to trilaterations, it has its own challenges too, that we have to know exactly the location of the access points. For the purpose of healthcare and monitoring residential locations, we don't always have access to information on the precise location of the access points. So maybe fingerprinting is the only options in those cases.
Okay, thank you.
Yeah.